Space adaptation syndrome. A space sickness is a condition experienced by around half of space travelers during adaptation to weightlessness. It is related to motion sickness, as the vestibular system adapts to weightlessness. Cause and remedy. Space motion sickness is caused by changes in g-forces, which affect spatial orientation in humans. According to Science Daily, gravity plays a major role in our spatial orientation. Changes in gravitational forces, such as the transition to weightlessness during a space voyage, influence our spatial orientation and require adaptation by many of the physiological processes in which our balance system plays a part. As long as this adaptation is incomplete, this can be coupled to motion sickness, visual illusions and disorientation. Modern motion sickness medications can counter space sickness but are rarely used because it is considered better to allow space travelers to adapt naturally over the first day or two than to suffer the drowsiness and other side effects of medication. However, transdermal dimenhydrinate anti-nausea patches are typically used whenever spacesuits are worn because vomiting into a spacesuit could be fatal. Spacesuits are generally worn during launch and landing by NASA crew members and always for extravehicular activities. EVAs are consequently not usually scheduled for the first days of a mission to allow the crew to adapt, and transdermal dimenhydrinate patches are typically used as an additional backup measure. History. Space motion sickness was effectively unknown during the earliest space flights as these were undertaken in very cramped conditions. It seems to be aggravated by being able to freely move around and so is more common in larger spacecraft. After the Apollo 8 and Apollo 9 flights, where astronauts reported space motion sickness to mission control and then were subsequently removed from the flight list, astronauts attempted to prevent mission control from learning about their own crash experience, apparently out of concern for the future flight assignment potential. As with seasickness and car sickness, space motion sickness symptoms can vary from mild nausea and disorientation to vomiting and intense discomfort. Headaches and nausea are often reported in varying degrees. About half of sufferers experience mild symptoms, only around 10% suffer severely. The most extreme reaction yet recorded was that felt by Senator Jake Garn in 1985. After his flight, NASA jokingly began using the informal Garn scale to measure reactions to space sickness. In most cases, symptoms last from 2 to 4 days. In an interview with Carol Butler, when asked about the origins of Garn, Robert E. Stevenson was quoted as saying, "Jake Garn was sick, was pretty sick. I don't know whether we should tell stories like that. But anyway, Jake Garn, he has made a mark in the astronaut corps because he represents the maximum level of space sickness that anyone can ever attain. And so the mark of being totally sick and totally incompetent is 1 Garn. Most guys will get maybe to a 10th Garn, if that high, and within the astronaut corps, he forever will be remembered by that."